So then you get the 5, the 10. This is 10. Here's your 5, and there's your 1. So that's how the Pascal's triangle is built. That's where these numbers are coming from. You always start off with the 1. It's the way you start and you end with the 1. And then the middles are the sum of kind of the row prior. Yeah? So you start with the 1, 1, 1. And then it is until you get to, if you have a degree of 2. Now it's 1. 1 plus 1 is 2. There's your 1. Start with the 1. 1 plus 2 is 3. 2 plus 1 is 3. 1. And then 1. 1 plus 3 is 4. 3 plus 3 is 6. And that's how it's built. Okay? And then really, so you don't have to memorize the binomial expression, because then what happens is, okay, so here's what we're going to do. This is a degree of 3. So I'm using this row right here. So that means with a degree of 3, I'm going to end up with 4 terms. 1, 2, 3, 4. Okay, so I'm going to expand it here. I know I have a 1, I have a 3, and I have a 3, and I have a 1. So these are my 4 terms. Okay, 1, 2, 3, 4. I'm going to have 4 terms. If you look at your binomial expression, there's my 1. Here you can't see. 1, 3, 3, 1. So Pascal's triangle is just the coefficient pool. It kind of simplifies this, because once you know the pattern of the first is decreasing, the second is increasing, you really just need to know the coefficients. And so 1, 3, 3, 1 is what we need. Okay, what happens? Remember, this is your A. This is your B. So when I tell you, well, here, let's circle, because you got to grab the negative 2. So this is positive 4m, and this is negative n. Okay. All right, so if the binomial expansion is saying the A is going to decrease, the B is going to increase. So if I have A, so let's work with the A's first. A is 4m, and my degree is 3, my exponent. So I'm going to go 3, 2, 1, and 0. You could go ahead and write it because we're in the beginning, but remember, everything times 1 or anything to the 0th power is just 1, right? So you could technically not write it. Some of you do. Okay. All right, so now go to the B term, which is negative n. You start at 0, and now you're going to work your way up. 0, 1, 2, 3. So this will be negative n to the 0, but that's just 1. Negative n to the 1, negative n to the 2, and then negative n to the 3, and it's perfect. And when you clean up these terms, you have it expanded, it's cleaned up. You just have to be careful about the 3. Anything that's in the parenthesis, if you have a exponent, a power, it has to apply to the 4 and the m. This 2 has to apply to the 4 and the m, right? That 3 is to the negative n. So that's now where you have to just clean it up nicely. Clean it up? Yeah? Okay, so if we take the first, so I'll do it in steps. Obviously, you guys can grab a calculator at some point and shortcut as you like. Okay, this is a 1. If you want to write it, you can. Remember, this is in a grouping parentheses. So that means you have a 4 to the 3 and an m to the 3. It has to go to both. And then here I have a 3. Same, the square goes to the 4 squared and the m squared. And then negative n to the 1. Remember, negative n is really negative 1 and an n, right? Okay, so are you guys okay with me just writing it negative n, or do you want the negative 1n? Negative 1n. Okay, so then here I have negative 1 and n. And it's only to the first power, so I'm not writing any of that, okay? That's in regards to this. All right, so now here I have 3. It's a 1, right? So you could just go 4m. And then here, this is a squared, so that means it's -1 squared. But remember, when you put in the calculator, if you're going to use a calculator, the negative has to go in the parenthesis, right? Otherwise, you're going to get a -n, but you should get a positive. And this is n squared. This is 1, this is 1, and so now this is -1 cubed, n cubed. And now you just clean it up more. And so you could do one term at a time and clean it up, or you could do it in parts. It's whatever you guys want. Keep going? Yeah. Okay, so what's 4 cubed? 4 times 4 times 4 is 64, right? 4 cubed is 64. So 1 times 4 cubed is 64m cubed. So there's my first term cleaned up perfectly. Okay, so now 4 squared is 16. So what is 3 times 16? 48. And then times that -1, right? So 3 times 16 times -1 is -48. And now I have m squared n, but that shouldn't be a problem because look, m3, m2, n0, n1. So far it's working out fine. And so that's where some of you students realize, oh, I just have to do this with the numbers. I don't even have to put the variables because I already know one's working down, one's working up. Okay, so you could even make this even easier. All right, now what? What's 3 times 4 times -1 squared? -1 squared is a +1. So what's 3 times 4 times 1? 12. And then you could go ahead and like pay attention to this. But remember, it's going 3, 2, 1. What's your n doing? 0, 1, 2. So you could look, but if you understand the pattern, it's really just the coefficients. And so lastly then, 1 times 1, -1, remember an odd number, right? An odd power to a negative number is just negative. So 1 times 1 times -1 is -1, and then n cubes. And so look, your m's are going 3, 2, 1, 0, no m, and then 0, so no n, 1, 2, 3, and so really it's just you cleaning up the coefficients and that's it. Okay, so if you do it just quickly again, if you know you have 4m minus n cubed, if you understand it's 3 squared n and 1 n squared m and then n cubed, then you understand that you're only looking for the front numbers. That's it, right? 1 decreases, 1 increases. You're looking at this, so you know it's 1, 3, 3, 1. You know your 4 is 4 cubed, 4 squared, 4 to the 1, and 4 to the 0. You could just leave it off. Why even write it? What's happening with this? What's this coefficient? It's -1. So -1, 0, -1 to the first, -1 squared, -1 cubed, and now really that's all you have to do. So what's 4 cubed? 64. This is 16 times 3 times -1, -48. This is +1. 3 times 4 is then 12, and -1, -1, and there you go, you're done. So you can, if you really understand the binomial expansion and Pascal's triangle, this is like really, really fast, but you're welcome to always expand it by hand if you want. Because it can look really messy, right, when you're putting all the variables and everything in, but once you remove the variables, it's really, really clean and pretty, and it's doable, and you're not going to make as many mistakes with like the numbers. Yeah? I like this. Okay. All right, just tell me when, I'll turn it off. Okay, so I'll leave you guys alone. I'll walk around. If you have any assignments to give me, I'll put them in. If you want me to do an assignment from a prior problem, I'll get them in. Yeah, and then I'll look. Oh, I left it at home. Bless you. You guys are first period. Did I update it? Yeah. Okay.